Alright, in this video I'm going to talk through the next two example problems from this objective. Remember, we're in topic 2, inverses of radical functions, and the objective is to find the inverse of a given function. So in a previous video I went through the notes here and I did the first two example problems. I did one, for example, I had you try the second one. And I'm going to go through numbers 3 and then I'm going to do number 6. I'm going to switch that around a little bit. 3 and 6 for examples as well, because they look a little bit different. The steps are still the same. I wrote them in red, so you can reference those as I'm going. And if you notice, the first two examples were linear equations. Now, the next example I'm going to do is a quadratic equation, or a power of 2. And please keep in mind as I'm going through this, if you're ever presented with an equation with a power, in this case the power of 2, then the inverse is going to have the root of that power. So this is going to be the second root, or just the square root. All right, our inverse is going to have a square root. In the problem you're going to do, it's 3x cubed, and so eventually your inverse is going to have the cube root. All right, so just keep that in mind, that the power and the root are inverses of each other. And to begin, for this I do problem number 3, f of x equals negative 2x squared minus 2. I always switch f of x to the notation of y. Remember, f of x is just a different notation for output. The same with y is an output. Alright, so I did that, and then I'm going to move on to step 2, which is to switch the locations of my x and y variable. And remember, we do that because all of the x values of the given function become the y values of its inverse. And we're going to look at that graphically as well. That is what happens, and that's why we switch the x and y values as we find the inverse algebraically. So if I do that, I'm going to have now x equals negative 2y squared minus 2. And again, just switch the location of those. Then the third step will look different every time, if you remember, but it says to solve for y as you would any equation. Remember, the inverse of a power is the root, and vice versa. So this is going to be a multi-step process. And I know that because my y is being multiplied with the negative 2. It has a power of 2, and also it has a subtracting, or a 2 is subtracting from it as well. So there's a couple different pieces I have to get rid of and move to the other side before I can get y by itself. Alright, so just consider that this will be a multi-step process for this specific one. The first thing I'm going to do is kick out the furthest thing away from my y squared. That negative 2 that's being multiplied with it right here is closer than this 2 that's being subtracted from it. So I'm going to add 2 to both sides. Alright? And when I add 2 to x, those can't combine, so I'm just now going to write x plus 2 equals negative 2y squared. And that was the first step of the process of step 3 of solving for y. Now, before I can take the square root of the power, remember that whatever is being raised to that power has to be by itself or isolated. In this case, the negative 2 does not have the power of 2. The only thing that does is this y. Alright, y is being squared. So I'm going to divide by negative 2 because they're multiplying. Remember, whenever they're next to each other, it's multiplication. And divide by negative 2 on both sides. And in this case, I know in my first example I separated it. I made it 1/2 x plus 2 divided by 2, which is 1. But we're going to keep it all together like that because eventually I'm going to take the square root of everything. So just leave it as x plus 2 over negative 2, sorry. So now I have, I'll keep it on the same side to help it visualize a little bit better. I have y squared equals x plus 2 over negative 2. I can move that negative out in front if I want. I'll just keep it there for now. Now the final step to get y by itself is to take the inverse of the power of 2, which is taking the square root. So I take the square root of one side. Whatever I do to one side, I have to do to the other side. And so now I'm going to switch locations. I have y equals the square root of x plus 2 over negative 2. And to write it in inverse notation, f inverse of x, so the inverse of the given f of x function is the square root of x plus 2 over negative 2. And I am done. Alright? So at the end of this video, I'm going to graph the given function from this problem and its inverse to make sure we did it correctly. But that is the answer. So at this point, please pause the video and try number 4 on your own. If you notice, it's step by step, very similar process, just different numbers. And you should recognize that since it's the power of 3, you should have a cube root in your inverse. All right, so go ahead and pause the video and try it on your own. And check your answer with mine when you're done. At this point, you should have paused the video to try number 4 on your own, and please check your work with mine. I have labeled my steps and squared in my answer. I got the answer of the f inverse of the function x equals the cube root of x plus 2 over 3. So please, again, the step by step, I switched the x and y's. I added 2 to both sides. I got x plus 2 equals 3y cubed, then I divided by 3 right here, and so I got x plus 2 over 3 equals y cubed, and then I took the cube root of both sides right here. Cube root and the power of 3 are inverses, they cancel each other out, and then I have y equals the cube root of x plus 2 over 3, and then I wrote it in function notation, and I'm done. If you did not get that for your answer, please raise your hand and I'll come by and check it. Now, the last example. All right, and then you're free to do the practice work. I'm going to switch this around. I'm going to have you do that one over there, and I'm going to do this one just because it's a little added step, so it looks a little bit different. But the process is still the same. If you notice, the major difference, and hopefully you can visualize this already, is that we just worked with functions that have powers. Now this function has a root. In this case, it's the 5th root, so I should be able to know that my inverse of this function is going to have a power of 5 with the variable. All right. So to begin, the first step is to switch this to y. G of x is now y, and then my second step is to switch the locations of x and y. And again, please don't be confused. All I'm doing is, instead of where I see x in that piece of the equation, I'm going to put a y in place of it. All right. So I'm going to put x equals the 5th root of y plus 2, and then minus 2 outside of the radical. All right, and then step 3, now we begin to solve for y. And this is going to look a little different. Again, if you notice, up here, y had a power of 3, and I had to get rid of the subtracting 2 and then the multiplying 3. Here, y has the 5th root. It's trapped underneath the radical. And before I can raise whatever underneath the radical to the power to get rid of the radical, I have to move any other pieces on the same side of that equation that are not under the radical, all right? And what I'm referencing is this 2 right here, all right? This minus 2 is outside the radical. I have to kick it to the other side before I can raise the radical piece to the power of 5. So I'm going to add 2 to both sides. So now I have x plus 2 equals the 5th root of y plus 2. All right, now my radical piece is by itself, and so we've isolated the radical, and now the purpose of doing that is now I can raise that isolated radical piece to the power to get rid of the radical. Y plus 2 exists underneath, so I'm going to group it so that I know that I'm raising the entire thing to the power of 5, and since I grouped the right-hand side, I have to group the left-hand side of x plus 2. Because remember, whatever you do to one side, you have to do to the other. And I'm going to group x plus 2 and raise it to the power of 5 as well. So the purpose of doing that is the power of 5 and the 5th root cancel out, and now I'm left with y plus 2. It's free underneath the radical. Now there is no more radical. I'm left with y plus 2 on the right-hand side, and I'm left with x plus 2 raised to the power of 5 on the left-hand side. And then one last step, because again, remember, we're isolating y. 2 is being added to y, so I have to subtract 2 from both sides. And please, I see this mistake a lot. That x plus 2, the plus 2 within the parentheses cannot add or interact with this 2 that I'm subtracting from the entire piece of x plus 2 to the 5th, because this 2 is inside the parenthesis, this 2 is outside the parenthesis, so they can't interact with each other. So I just write minus 2 at the end. So now I'm going to have x plus 2 to the power of 5, and that whole piece is going to have 2 being subtracted from it. So x plus 2 to the power of 5 minus 2 equals y. And then to finish it off, I write it in inverse notation. X plus 2 to the 5th minus 2. And I am done. So the given function, y equals the 5th root of x plus 2 minus 2, becomes the inverse, f inverse of x equals x plus 2 to the 5th minus 2. And if you notice, I had a 5th root, and now my inverse has a power of 5. You should always see that relationship, all right? Now, please pause the video and go ahead and try number 1. And also, if you notice, there isn't that beginning step. The radical piece, cube root of x minus 2 divided by 2, is not subtracting anything, so you don't have to add anything to the other side or subtract anything to the other side before you raise everything to the power of, hopefully you can recognize, power of 3. And then when you do that, remember, in order to get that 2 out of the denominator, you have to do something very specific to both sides. Alright, so please pause the video and try number 1 on your own and check your work with mine. At this point, you should have paused the video and tried number 1 on your own. I have shown my work. I switched the x and y locations, and then I began step 3, solving for y, or isolating y, or getting y by itself in purple. Alright, so again, the first step of getting y by itself in this case was raising the entire right-hand side to the power of 3, because if you notice, the radical was also already isolated, so I didn't have to do anything before that. And whatever I do on the right-hand side, raise to the power of 3, I had to raise on the left-hand side. And I put x in parentheses just to remember the process, but x is by itself, so that 3, the power of 3, just interacts with x here. So now I get x cubed equals y minus 2 divided by 2, all that divided by 2, remember, because the power of 3 and the radical of 3 cancel each other out, so underneath is what remains. And then remember, to get anything out of the denominator right here, this 2, I have to multiply by it on both sides. So this multiplication of 2 cancels out with the denominator of 2, and I have to multiply the other side, so then I get 2 times x cubed, which becomes 2x cubed, and then equals y minus 2, and then I added 2 to both sides. Again, this 2 cannot interact with that 2 because they are different terms, and so I just write it afterwards. So my final answer, the f inverse of the function x equals 2x cubed plus 2. Now, if you didn't get that, please raise your hand so I can check your work. And I'm just going to graph this last example to double check that the graphs are reciprocals across the line y equals x. So please follow along on the website Desmos with me. On Desmos, I'm going to graph the function that was given to you in your practice problem, y equals the cube root of x minus 2 divided by 2. So I'm going to type y equals, and then I'm going to go over to the functions option and hit the miscellaneous tab, and this option here, n with a radical. Up there, I'm going to press 3 and then type in the function. I'm going to put parentheses x minus 2 so it knows that it's grouped. Close the parentheses and then divide that by 2. Alright, so that is the original function. Alright, it's a cube root function. And then I'm going to graph the inverse that we found, 2x cubed plus 2. 2x cubed plus 2, yes. So y equals 2x caret sign cubed plus 2. Alright, so some key features here. Mainly I want to talk about, before my video runs out of time, mainly I want to talk about this x-intercept right here of the original function is 2, 0. And because these two functions are reciprocals across the line y equals x, that line in green, because they're reciprocals about that, you see how the original function in red, 2, 0, is the x-intercept. Its inverse in blue, that x-intercept becomes the y-intercept of the inverse function. And again, that is because all x values become all y values. All x values of the given function become the y values of its inverse, and vice versa. And you can see how it is reciprocal across the green line y equals x. Alright, thank you for watching. Happy practicing.